So we were talking about the concept of torque, right? And I had showed you the concept of equilibrium, where you can equate the torque to zero, right? कर लिया था ना हमने equilibrium. ब्रेक नहीं मिला प्रसन्न. Don't worry, I will leave you early. Don't worry. ठीक है ना? I will leave by 12 o'clock. Don't worry. Next break आपको लंबा मिलेगा. So we had equilibrium हमने किया था ना. हाँ, उसको कंटिन्यू करेंगे. एक just hold on. So what we want to talk about is going ahead, moving ahead. We want to talk about Newton's second law. Although I have already done so, we want to talk about Newton's second law, rotational mechanics. Kinematics जो है वो इसके बाद करेंगे, ठीक है ना? Do that in the next. So this is not very difficult. Okay. Follow me very carefully. I think this should be a problem. So when we talk about translation, then the second law is F is equal to ma. Therefore, for the rotation, second law must be torque is equal to I alpha. Equilibrium था, इसलिए अल्फा की वैल्यू 0 थी, तो टॉर्क की वैल्यू 0 थी. You should really write summation of force. But now we are going to see cases where this alpha is not 0. There is no equilibrium, right? So it's just like if you remember class 9th में करते थे ऐसे या 10th में, I don't know. There is a 10 kg block and I am applying a 20 Newton force on it. What is the acceleration of the block, right? So the answer is very simple. You simply say that, look, force is equal to 20 and you have given mass as 10. F is equal to ma, so this implies that A must be equal to 2 meters per second square, right? In the same way, in exactly the same way, we are going to find out the torque on a system and we are going to equate it to alpha. There's a slight difference, however. The difference is that this torque must be defined about a point. So you cannot simply say that the torque on an object is 500 Newton meter. Right? We have discussed this. Unless and until saying that 100 Newton meter is insufficient. हाँ, ठीक है आवाज. So saying that, I'm repeating, yes. Saying that the torque on an object is 100 Newton meters is a nonsensical statement. Why? Because you have not defined the axis of rotation. Saying that the moment of inertia of an object is 100 kilogram meter square is a nonsensical statement because you have not specified the axis of rotation about which this moment of inertia is measured. Okay? And as we have discussed before, for the same rigid body, for the same object, the number of moment of inertias is infinite. Okay, and for the same uh, for the same body under the influence of the same forces, the number of torques is infinite. It will depend on your choice of axis of rotation, right, or your choice of origin. So therefore, when you apply torque is equal to I alpha on a system, this is what you must keep in mind. So summation of torque is equal to I alpha, right? So the torque and the moment of inertia, both of them, they must be measured about the same axis. So you cannot say that, look, I will measure the torque about this axis and I will measure the moment of inertia about this axis, I mean a different axis, and then apply a torque is equal to I alpha, right? This is not allowed. This is not correct. You cannot do this. जिस एक्सिस के अबाउट टॉर्क मेजर हो रहा है उसी एक्सिस के अबाउट आई भी मेजर होएगा. Okay. The best part here is that alpha, that is the angular acceleration, it happens to be independent of choice of axis. This means that wherever you choose your axis, alpha will be same. This is independent of the choice of axis. You can choose any axis, alpha is same. अब इसका proof भी है, but I'm not going to tell you the proof because it is very cumbersome and lengthy, so we'll not talk about the proof. But the fact remains that if a rigid body is rotating and you choose any axis, then about that axis, the angular velocity or the angular acceleration will always come out to be same. So please take a screenshot. I'll show you the application of this. Please take a screenshot. I'll show you the application of this. Okay. नहीं मैं सारी चीजें ले डाउन कर दे रहा हूँ. When do I apply torque is equal to IL? Right? And the answer is whenever the rigid body rotating. So if you have a rigid body which is rotating, that means you have to apply torque is equal to I alpha. Okay? This also would mean that if it is not rotating, the net torque is zero, or net torque may be zero. Which axis do I choose? Okay, now, like I have said, that there is an infinite choice. You can choose any axis you want. However, we are going to have no choice. Or at least you are going to have no choice for the moment. Later on, I will show you how to apply this about a different axis, right? But that will be at the end of the chapter, because as far as we are concerned, as far as जो हमारा लेवल है उसमें हमें ये एक्सेस की मल्टीपल चॉइस से काम नहीं करना है, राइट? हमें कंफ्यूजन या एम्बिग्युइटी हमें नहीं चाहिए। वैसे ही ये चैप्टर जो है बहुत भारी है, ऊपर से यदि एम्बिग्युइटी आ जाएगी तो और कंफ्यूजन हो जाएगा। सो देयर इज नो कंफ्यूजन हियर। So if the rigid body is fixed at a point, so now I must first define fixed. Fixed point is one with zero velocity. Okay, so you see a rotating object and you see a point which is fixed. Now this point which is fixed, maybe this information may be supplied to you in two different ways. Okay? May be supplied to you in two different ways. First way is that I will tell you that look, the rigid body is actually fixed from this point. किसी ने कील गाड़ा हुआ है, नहीं, एक्सिस नहीं सर, डोंट, जो मैं बोल रहा हूँ उसको सुनो। What you are saying will coincide with what I am saying. So if the rigid body is fixed at a point, fixed कैसे मैं बताऊंगा आपको? दो तरीके हैं। पहला मैं बोलूंगा भाई मैंने उसको कील से गाड़ दिया है। For example, I take my pen and I take a nail and a hammer and I place my pen vertically against a vertical wall, and then 2 centimeters from the top of the pen, I put the nail and I strike it with the hammer until the nail goes through the pen and into the wall. Okay? So when that happens, I have fixed that point on the pen, right? So the pen now is free to rotate about that point, about that nail. But of course, because of the nail, that particular point, which is 2 centimeters from the top of the pen, cannot move. It has been fixed. There is another option of telling you that a point is fixed. And I can say that, look, in this rigid body, this particular point has zero velocity. Right? Both statements are equivalent. मैं या तो बोलूंगा इस पॉइंट पे फिक्स्ड है, बिल्कुल सामने ही सामने आपको परोस के दे दिया, या मैं बोलूंगा कि इस पॉइंट की वेलोसिटी zero. Both statements tell me that that is the fixed point. And if a rigid body is fixed at a point, then this implies that the fixed point is the origin. Okay, so if you have in front of you a rigid body which is fixed at a particular point, then the torque will be calculated about that point, and angular acceleration the same होगा, and the moment of inertia will be calculated about that particular point. Okay? So I want to give you a question here. Question 1. A rod of length L and mass M is fixed at a point L by 4 from top as shown. It is released from rest as shown. Fine. So we have this is the rod. This is the fixed point. This distance is L by 4. Obviously, then that means that this is 3L by 4. And I'm also telling you that this angle is theta. A. Net torque on rod about fixed point. Moment of inertia of rod about fixed point. Angular acceleration of rod when it is just released. बाद में कैसा मोशन हो रहा है उससे मुझे कोई मतलब नहीं. जैसे ही रिलीज किया, आई वांट द values of these things at that point. Sorry. मेरी बात इतना सब होता है. हाँ, क्वेश्चन में दिखा रहा हूँ. नहीं भाई, पहले टॉर्क बताओ कितना आएगा, पहला आंसर बताओ. वेरी गुड. यस. मोमेंट ऑफ इनर्शिया निकालो. Yes, sir. काटा था? पैरेलल एक्सिस थ्योरी भी तो लगाना है ना? और 7 ml square by 48 ml square by 12 plus ml square by 16. सेवन आना चाहिए, 19 पता नहीं कैसे आ रहा है तेरा। दोनों को इक्वेट कर दो। इक्वेट मतलब इक्वेशन में डाल दो, टॉर्क इज इक्वल टू आई मोमेंट ऑफ इनर्शिया पैरेलल एक्सिस थ्योरम लगाना होगा। ml square by 12 plus ml square by 16. टॉर्क इज इक्वल टू आई अल्फा। बिल्कुल सेम क्वेश्चन है ये जो मैंने क्वेश्चन यहाँ दिया हुआ है, दिस क्वेश्चन हियर। फोर्स दिया है, मास दिया है, ए निकालना है। टॉर्क फाइंड कर लिया, आई फाइंड कर लिया, सेवेंटी वन कहाँ से आ गया?
7L है।
अच्छा ओके। Okay, let me show you. First, I draw the forces acting on the object. Then I extend the forces and I drop it perpendicular from the chosen origin. So I know that this distance is L by 4. Therefore, this distance must be L by 4 sine theta, I think. So for part A, torque is equal to mg L by 4 sine theta. This I am writing clockwise for my reference. Okay? That is a habit that you should also have. B. Please also notice that there may be other forces acting on the object due to the fixed point, due to the nail that I have driven through the rod. But all these forces will be acting like this or like this or like this. They must be acting from my chosen origin. And therefore the torque due to these forces must be 0. Okay, I'm not going to consider these forces at all. Okay. B part, moment of inertia, ml square by 12. This is ICUM plus m into L by 4 whole square. This is mh square.
सर इसमें हम लोग ml square by 3 से नहीं ले सकते ना?
ये एक्सिस के अबाउट मेरे को मालूम है, ये एक्सिस के अबाउट मेरे को निकालना है, ये दोनों एक्सिस पैरेलल है. Both the axes are out of the plane, so both the axes are parallel. What is the distance between them? Now
L by 4.
L by 4. So therefore we get कितना आ रहा है, ये वर्कआउट किया था ना,
7 ml square by 40.
right? So now everything is over. Now it is just f is equal to ma basically. So we will write mg, I क्यों लग रहा है, mg L by 4 sin theta is equal to 7 by 48 ml square alpha. So m cancel हो गया, L cancel हो गया, cancel हो गया, 12g sin theta divided by 7. हाँ, बिल्कुल सही. ठीक है, आया सबको ये समझ में? Everybody has understood this. If the rigid body is free to move, center of mass is the origin. Okay? The rigid body is free to move. Center of mass is always the origin. Okay? Now we are not going to today discuss the second Ola case. We are going to stay at the first Ola case, and in the next class I will discuss some more things, some kinematics. Once we have done that, then we can come to the second case. For the moment, we are going to stick to the first case, right? But you have to just remember, it's very easy. Fixed point है, rigid body के ऊपर तो fixed point origin रहेगा, और अगर rigid body के ऊपर कोई point fix नहीं है, तो center of mass origin रहेगा. Please take a screenshot of this. And this. So we have seen this times before, but now there is a catch. Like I told you that we are moving from the world of it can rotate, yes. We are moving from the world of ideal objects closer to the world of real objects. So when we were studying Newton's laws, we had assumed that the pulley or any pulleys occurring in the system are ideal objects, and ideal ka matlab tha that they are massless. Okay? They are massless, frictionless, everything that is not physically possible. Now we come a step closer to reality, and we say that now the pulley has a mass of m. The consequence of coming closer to reality, the consequence of this pulley not being ideal has implications. For example, I'll just change the slide for a minute and I'll come back. For example, we did a question like this where we had a block here and we did a question like this. So in this case, if you looked at this part of the system, if you had assumed that the tension here is T, then the tension here becomes 2. There are two things happening here. Let me show you what two things are happening. Number one is that we are assuming that tension on both sides of the pulley are same, right? And this was a very simple thing that I had taught you, that if the string is same, then the tension is same throughout, irrespective of however many pulleys it goes upon, right? And then we have this guy, and this guy comes from the fact that since mass of the pulley is assumed to be 0, therefore net force on the pulley must also be equal to 0. नीचे अगर T और D लगाए तो ऊपर 2T होना चाहिए, right? Now both नहीं बेटा गलत, both these assumptions are invalid in case of pulley with mass, yeah? Or not ideal pulley. Unideal. Unideal is a word. Please take a screenshot of it. This is very, very important. जब हम मैकेनिक्स शुरू कर रहे थे तो पुली मास सिस्टम्स को एनालाइज करने के लिए हमारे पास ये तरीका था. दिस वाज द वे दैट सेम स्ट्रिंग है तो सेम टेंशन रहेगा, पहला चीज. और दूसरा, पुली के ऊपर नेट फोर्स हमेशा 0 रहेगा. Now both these things will not hold true if the pulley has mass. If the pulley does not have mass, no problems. Everything is back to normal. But the moment I write M next to a pulley, the moment the question mentions the pulley has mass or the pulley has moment of inertia, that's it. Both these statements now become invalid. This means that tension on both sides of the pulley will not be same. And this means that if you have a pulley, then the net force on the pulley may or may not be equal to zero. That means that pulley may have an acceleration of its own now because the pulley has mass. So instead of writing T2T, now the situation will be that you will be writing here. So let me draw it like this. So you will be writing here T1, you will be writing here T2, right? And you will be writing here T dash, where T dash will be equal to T1 plus T2 plus minus mg T1 minus T dash minus is equal to m. इस टाइप में कुछ है, right? So ये हमारे सामने कभी आएगा नहीं, but the point is that this thing will not work. ये 2T वाला जो concept था, अब ये काम नहीं करेगा. You cannot do this anymore. I'm coming. So going back to this question. Okay. Now, again, please follow me very carefully. So now we have three objects in the system. Right? These three objects are two masses and a pulley. So what you need to do is you need to identify the motion of these objects. So for M1, we have what is happening? Translation is happening. The moment you see translation, everything is the same as before. So you will draw an FBD, M1G नीचे act कर रहा है, T1 ऊपर act कर रहा है. Because now the tension here must be T1, tension here must be T2, tension here must be T2, tension here must be T2. So on two sides of the pulley, the same string has it. On two sides of the pulley, the same string will have now different values of tension. Why is this? Because the pulley has mass, because the pulley is not ideal anymore. उसके बाद से M2 क्या कर रहा है भाई? What is M2 doing? So for M2, again we notice that M2 is executing translation. So we will draw the FBD M2G. Now I am assuming हाँ बात मैंने केवल ये बताया कि M1 M2 are translating, right? And I know I can see given in the given problem M1 M2 are translating. Therefore, I just draw the normal FBDs and I'm going to write F is equal to MA equations for them. Now it is given that M2 is greater than M1. Therefore, I know that this guy will be going down with an acceleration A. This guy therefore will be going up with an acceleration A. And therefore, the equations of motion that I'm going to write are T1 minus M1G is equal to M1A. And here I'm going to write M2G minus T is equal to M2A. Now, please, everyone, if there is anything that you are not understanding, if there is anything which is, थोड़ा सा भी doubt create कर रहा है, please ask before I move to the main point of the problem. Please ask. Okay, so I'm assuming that everybody is understanding what I am just saying. Okay? Now we come to the main aspect of the problem where we T1, T2 same नहीं. Very good job. बहुत good. T1, T2 सेम नहीं. अगर पुली आइडियल नहीं होगी, अगर पुली का मास होएगा, तो हमारा जो ओरिजिनल assumption था कि एक स्ट्रिंग में टेंशन सेम रहता है, वो assumption अब valid नहीं होगा. So the pulley will have will have different tension. Same string will have different tensions on the two sides of the pulley. Okay, now I come to the third object of the problem, and that is on M. And I notice that since M is fixed, free to rotate, it must be executing only rotation. It must be executing only rotation. And if M2 is moving down and M1 is moving up, then it must be rotating clockwise. This must be alpha. So for M, there is rotation. And I must write down here that since M2 is moving down and M1 is moving up, therefore M must have clockwise rotation. Okay, now I'm going to draw the FPD. What are the forces acting on this? T2, T1, Mg, T dash. But remember, if a rigid body is fixed, then that fixed point must be the origin. So this red dot must be the origin. And if this red dot is the origin, then the torque due to Mg and T dash is 0. So what is the torque on the? Well, it must be T2R clockwise plus T1R anti-clockwise. ये कैसे आया? Remember, keep your pen on the head of the vector and twist it towards the origin. Keep your pen on the head of the vector, twist it towards the origin. That will tell you the direction, sense of rotation of the curve. Now, since one is clockwise and the other is anti-clockwise, this means that one should be positive and one should be negative. Okay. Now I have to choose. किसको positive लेना चाहिए, किसको negative लेना चाहिए. To answer this question, I come back to these two equations. Why have I written T minus mg in one and mg minus t in the other? Why have I written T minus mg in one and mg minus t in the other? Why have I written T minus m1g for the first block, m2g minus t for the second block? Because we know that the acceleration of the second block is downwards. Therefore, we have taken for that block the downward forces as positive, upward forces as negative. Yes, sir. Yes, good. For the first block, we see that the acceleration is upward, so we have taken upward forces as positive and downward forces as negative. Although the standard dictates that up must be positive and down must be negative, but we are not bound by these standards. They are not for us. We can decide on our own. And for the second block, indeed, we have decided that the downward direction is positive and the upward direction is negative. In exactly the same way, I see that since the very good. since the pulley is rotating clockwise, the clockwise torque must be greater than the anti-clockwise torque. Okay? Therefore, the clockwise torque I will take positive and anti-clockwise torque I will take negative. So I will get T2R minus T1R. This is the net torque. This must be equal to I alpha, which is mr square by 2 into alpha. So this is equation number 3. This is coming from where? This is coming from torque is equal to I alpha, which is Newton's second law for a rigid body. Right? This is coming from where? Equation number 1, F is equal to ma, which is Newton's second law for a translating body. तो जो ट्रांसलेटिंग बॉडी था उसके ऊपर मैंने नॉर्मल एफ इज इक्वल टू एम ए लगाया, जो रोटेटिंग बॉडी था उसके ऊपर मैंने टॉर्क इज इक्वल टू आई अल्फा लगाया. And this is again coming from F is equal to ma. However, after applying all these things, I noticed that the number of equations is less than the number of unknowns, because T1 is unknown, T2 is unknown, T2 is unknown, T1 is unknown, A is unknown, and alpha is unknown. 4 unknowns. Right? However, it is very easy to find a relationship between alpha and A, because there will be a statement in the problem which I have not written, but I will write it down. There will be a statement in the problem, and that statement will be no slipping occurs. Okay. Now, I am not going to write this in every question, in every problem that I give. Very good, sir. Yes. I am not going to write this down in every problem that I give. Okay. Sir. Good, sir. So we are going to इसका मतलब कुछ और है. So we are going to assume that no slipping ever occurs, and again I will relegate to the end of the chapter the concept of slipping. So until and unless we come to that point where I say, okay, now we want to study the concept of slipping, you will not ever assume that slipping is occurring. Always slipping will never occur. What is the meaning of this? Well, the meaning is actually very simple. अगर हमने ये पुली के ऊपर ये बेल्ट या ये स्ट्रिंग लगा के रखा है और मैं बोल रहा हूं कि स्लिपिंग नहीं हो रही, इसका मतलब बहुत सिंपल. इसका मतलब ये है कि अगर ये पुली क्लॉकवाइज थीटा एंगल से रोटेट करता है, अगर ये पुली क्लॉकवाइज थीटा एंगल से रोटेट करता है, then the amount of string which will be released here will be r theta, and the amount of string which will get wrapped on the pulley will be r theta. Right? What does this mean? Simply means that the relative motion between the string and the pulley is zero. After all, that is what it means. No slipping. When you are walking on the road, you are not slipping. So you keep your shoes, when you put your shoes on the floor, when you put your shoes on the ground, when you put your feet on the ground, right? And let's say that you have put some paint at the bottom of your shoes or your feet when you are walking on the ground, on the floor. Then what will happen is that your shoes are going to make an exact footprint on the floor. Right? This tells me that the shoe has not slipped. If the shoe did slip, then the paint would be smeared. Right? So in the same way, when this pulley turns, the string also moves in such a manner that the string does not slip on the pulley. Right? So this means that if the angle turned by the pulley is theta, and if the string is increased in length by r theta, this means that this guy goes down by r theta, and this guy goes up by r theta. So basically what I'm saying is that look, the displacement of the object is equal to r theta. If I differentiate this once, I'll get v is equal to r omega. And if I differentiate this get to r alpha. Okay? And this is equation number 4. So there is a relationship between A and alpha. Right? गड़बड़ है थोड़ा सा connection गड़बड़. Please take a screenshot. Please take a screenshot. I'm moving to the next screen. Please take a screenshot. Let's write all the equations. One G is equal to M1. हाँ हाँ रुक जाना सब टाइम क्या बेचैन मत. So T minus M1G is equal to M1A. M2G minus T2 is equal to M2A. Okay, and then T2R is equal to yes, minus T1R is equal to MR square by 2 into alpha. But A is equal to R alpha, so alpha must be equal to A by R. Therefore, I write here A by R. If I do that, R cancels out. Basically, I have to add these three equations. When I add these three equations, T1 minus T1 minus T2 plus T2. So I end up on the LHS M2G minus M1G is equal to M1 plus M2 plus M by 2. Sorry. A. So A is equal to M2 minus M1G upon M1 plus M2 plus M by 2. नॉर्मल एटवुड मशीन का याद है सबको क्या होता था एक्सेलरेशन जो हमने एनएलएम में पढ़ा था याद है क्या होता था एनएलएम में
सर नीचे m/2 का टर्म नहीं रहता.
नीचे m/2 का टर्म नहीं होता. हाँ. So if you are to carry out this experiment, measure the acceleration in the real world, then you would find that the expression for acceleration in an ideal pulley wala case, that is M2 minus M1G upon M1 plus M2, will be not as accurate as the real value as this M2 minus M1G upon M1 plus M2 plus capital M by 2.
मतलब हम लोग जो एक्सेलरेशन निकालते थे वो ज्यादा रहता था.
हाँ. Yeah. We'll start doing HCV now.
सर आप एक लास्ट पेज दिखाओगे?
हाँ.
सर इससे बाद वाला।
बाद वाले पे तो थे।
जिसमें हाँ ये वाला।
भैया
हाँ सर।
HCV now you can do आराम से 30-35 क्वेश्चन तक आराम से कर सकते हो, कोई प्रॉब्लम नहीं आनी चाहिए। ये वाला क्वेश्चन ठीक।
सर लास्ट स्लाइड था।
Okay, so I'll stop here. Next class में we'll take this further. If you see an object which is executing translation and rotation simultaneously, you won't be able to do that right now. Apart from that, आप start कर दो HCV, अब moment of inertia वाले problems करने हैं, उसके बाद से torque निकालने वाले problems हैं, उसके बाद से basic torque is equal to I alpha वाले problems हैं। लेकिन जहाँ पे rotation and translation हो रहा है, उसके लिए you'll have to wait for one more class. Okay? चलो, so now you can have your break. ठीक है? किसी को कुछ डाउट समझना है और चलो okay. हाँ, एग्जाम में ऐसे ही क्वेश्चन है। Yes. चलो बाय बाय।